First, I have to apologize for a delay because I forced to stay in Hong Kong for over one night because my airplane was broken. So I just arrived, so if I say something wrong or something strange, just let me know. Okay, so first of all, it is my great pleasure to be here the second time to introduce my work about the MDS. So we start from anemia. This is a US data. After 50 years old, anemia prevalence rate rose rapidly and is the greater than 20% at age 85 or older. And those patients, there's a group of patients called unexplained anemia that contribute 1/3 of anemia in older ages, not patient. So in those population, at least 70% met one of three criteria of myelodysplasia syndrome, including macrocytosis, leukopenia, and thrombocytopenia. So what is myelodysplasia syndrome? I believe some of you already know that. That is a hematopoietic cell dysplasia. Initially, we define that as at least 2 of 3 hematopoietic cells got dysplasia, but now WHO get new classification. Most of patients belong to old age, related to old age, 60 to 75 years old. And WHO classification, we can see so many, including refractory anemia, RARS, refractory anemia with ring sideroblast, and unilineage dysplasia, and multilineage dysplasia, and so on. Then that is gradually progressed to leukemia, REB1, refractory anemia with excess blast. 1 means blast less than 10% in bone marrow, but more than 5% in bone marrow. And 2 means more than between 10 to 20 in bone marrow, the blast count. And NDS-MPN and unclassification and spatial 5q syndrome. Anemia is the most uniform present in NDS patient, and we don't want this kind of patient progress to acute myeloid leukemia because that is very tough to be treated, even worse than native acute myeloid leukemia. And that has been reported that iron overload related to amyloid transformation. So this is a picture of bone marrow. We can see that myeloid dysplasia with hypogranulation, and this is erythroid dysplasia with multiple nucleus. Hypermethylation is one main mechanism of MDS. So there is a medicine called azacitidine that is demethylation that work well in NDS patient. However, not every NDS patient can work with this kind of medicine. So we try to figure out what's wrong with that, and so many gene mutation has been reported. Most of these genes are related to AML. Just because iron overload is one critical point for leukemia transformation, then we talk about a little bit iron utility in mammalian cell. We know iron is very critical in mammalian cell for survival, growth, and differentiation. And mammalian cells and tissue contain low molecular weight 0.4 that bind iron with high affinity. LCN2 can bind this small molecular weight ligand, and that involved many biological processes, including apoptosis, innate immunity, and renal development. That has been reported in many papers. So BDH2, CIDR4 is that a small molecular ligand, and BDH2 is an enzyme that belongs to short-chain dehydrogenase family reductase that control the rate-limiting step of mammalian CIDR4 biogenesis. And that also controls mitochondrial metabolism, and we know that there has been report that depletion of BDH results in abnormal accumulation of cellular iron and mitochondrial iron deficiency. not only mitochondrial metabolism, they also control keto body synthesis and degradation. This is from Cell in 2010, and in this paper we know that BDH2 is required for 24p3. This is LCN2 mediate iron transporter. So we can see the upper 24p3 cannot be increased in BDH2 knockdown cells, and also control the apoptosis, that increase apoptosis rate in BDH2 knockdown cells. So if cell have a lot of iron in his cells, in his cytoplasm, then they will control BDH2 mRNA expression, and they will stop the BDH2, and that will decrease the mammalian cellular force formation, and then they will stop the mitochondrial iron transformation. Yeah. So CD4 protects cells from oxidative stress under hydrodeoxide treatment. So we can see in BDH2 knockdown cells, they can see more apoptosis cell happen. So based on the previous data, we suggest one thing, that BDH2 is, if BDH2 related to different subtype of NDS, or ferritin is an iron accumulation particle in our body. Ferritin at diagnosis that is not related to blood transfusion, is related to leukemia change or survival. Is that true? And BDH2 related to ferritin or not? And that influence on leukemia-free survival, or overall survival. So first of all, we enroll 199 newly diagnosed patients with different subtype of NDS from 2001 to 2012. Only 187 patients with good quality of bone marrow sample can be enrolled. And we also choose 43 patients with normal bone marrow, that is from lymphoma patient without bone marrow invasion, and as an active control, and we choose 119 cytogenetic normal AML patient as a positive control. And we use real-time qRT-PCR to detect. For statistics, we use SPSS 17 to analysis. And ANOVA, we use ANOVA correlation regression, and we use ROC curve to predict BDH2 cutoff value. And we use Kaplan-Meier analysis to analysis survival, and chi-square to do the other two groups analysis. So this is our patient's data. We divided to low BDH2 based and high BDH2 expression group based on ROC curve. So we can see the rate. There's no different in age, sex, and white blood cell, HB, NCV, even platelet in two different groups. However, we can see in high BDH2 expression group that we have high ferritin expression, and that is not related to blood transfusion because we exclude that kind of patient. And according to different type of NDS, we can see that more aggressive type had higher BDH2 expression patient group, and low BDH2 expression group got lower risk of patients. And according to IPSS-R score, we also see the same phenomenon. Higher BDH2 expression group got higher high risk and very high risk patient. However, low BDH2 expression got low expression patient, a more low expression patient. However, we cannot see very low expression have any difference because there's too limited patient number. And we can see leukemia progression rate is higher, much higher in high BDH2 expression patient compared with low BDH2 expression patient. It's 15.25% to 3.77%.
Okay.
Okay. Okay. Okay. Fix it. Okay, so we can see in different NDA subtype got different BDH2 expression, and that has significant statistics meaning. We can see that leukemia progression and de novo AML patient got higher BDH2 expression. This is delta BDH2, so low means high. So normal patient and RA-RSRA patient get lower BDH2 expression in mRNA level, and we see opposite phenomenon in LCN2 expression. We analyze the relationship with BDH2, LCN2, and ferritin. So we can see BDH2 and ferritin has a negative correlation. However, there's no correlation between BDH2 and LCN2. Even previous report told us that LCN2, BDH2 control CD4 and CD4 relate control LCN2. And based on BDH2 group, high group and low group, we also see the same phenomenon that high group have higher ferritin level and low group have lower ferritin level. It's got statistics, the significant. So according to IPS score, we can see high group got high expression of BDH, low got low BDH2 expression. So for survival, we can see that in BDH2 expression, we can see that influence on leukemia-free survival. Lower BDH2 had better leukemia-free survival. However, there's no significance in overall survival. And ferritin, that is already reported that related to overall survival in NDS patient. And we can see the same phenomenon. We cutoff value is 350 based on the others' experience. And we did not see the significant difference in leukemia-free survival. However, the two lines did indeed separate. So we can see that BDH2 related to ferritin and that influence on leukemia-free survival, how it happened. We want to know what is the pathogenesis of BDH2. Is that because of apoptosis cell cycle, retardation, or cell differentiation different, or others? And what kind of cells in bone marrow got higher BDH2 expression? So we create BDH2 knockdown cell line of THP1, and we use real-time qRT-PCR and Western blot to detect BDH2 knockdown efficacy, and we do cell cycle arrest using non-serum starving model and flow cytometry for cell cycle and for apoptosis assay, and spatial stain and IHC for protein expression. So first of all, we use retrovirus. It's from Sigma, and we use impuromycin to select. This is RNA label. We did see the knockdown efficacy especially in SH, the third one. And the protein level show also the third one is lowest expression. So we choose shRNA BDH2 versus the third one. This is the lowest expression one, and the other one as a compare the growth rate. We can see that BDH2 knockdown cell line has lower growth rate and related to dose. So the first form, apoptosis, should be considered. We did see that phenomenon that BDH2 knockdown cell has high apoptosis rate. And that is passed through surviving pathway. And we also want to know if differentiation is the other mechanism for that. We did see that. We can see that knockdown cells have higher expression of CD11B and CD15. This one, 15, is for monoserous, and 11B is for myeloid serous. And this is why we choose THP1, because it can become these two different cells. And we can see from the MPO and NSE stain, we can see knockdown cells has higher expression of MPO and NSE. NSE is stand for mononuclear cell, monocyte, monoserous cell, and MPO is stand for myeloid cells. And we also see one interesting phenomenon, this new stain only. We can see knockdown cells show some larger cells inside, and this is native THP1, this is control cell, all uniform. However, knockdown cell has some macrophage phenomenon. Then we want to know cell cycle. So we noticed that knockdown THP1 cells also show cell cycle retardation. This is the normal one. We can see the S phase is around 4 days, got the plateau, and the knockdown one, it has been to the 4th days, they can start the S phase. So this is, I believe nobody can read this picture because too small words. That's what we want to know, if the other downstream DNA or RNA will be influenced by BDH knockdown cells. So we use BDH knockdown cells and control cells to do microarray, and we do find something. And we notice that BDH knockdown will influence on mitochondrial metabolism pathway, and also related to some tumorigenesis and oncogene. And also citrate pathway will be influenced on, and also cell differentiation pathway. We can see that difference. Okay, so the last question we want to know is which kind of cell is BDH2 distribution. So this is control cells, and this is BDH2. We use BDH2 immunostain, and we notice the red one, this is HE stem, so the red one is erythroid blast, normal blast, and this one, the white one, is myeloid blast. So we can see both cells get high expression of BDH2. So no matter myeloid or erythroid, we can get BDH2 stem. So the conclusion, we know that BDH2 can increase the risk of leukemia change in NDS patient. So it can be a predictor for leukemia transformation. And we use the BDH2 knockdown cells to find out what is the pathogenesis. And we found that BDH knockdown cells showed cell cycle retardation and can stimulate cell differentiation and will increase apoptosis. And that may through many pathways, and the finally will cause cell growth retardation. So BDH2 we also proved that BDH2 is expression in both erythroid and myeloid cells, not only erythroid cells. Okay, so any questions?
Questions?
This is very preliminary data.
Yeah, but having a marker, the promise of a marker,
yes,
is really extraordinarily valuable, because this syndrome is just a dark cloud over the heads of patients. And
yes,
it
yes.
would be useful,
and especially
certainly,
older patient.
Yes.
Yeah.
To have BDH2 as an acceptable marker. Okay, terrific. Thank you very much.
Thank you.